nearby and my office is nearby. I can't completely disentangle myself and be here all the time. So keep shuttling a little bit here and there. So in case I'm not around, I probably am running to my office to get things sorted out. Uh, Folks who come from outside, it's a lot more easier. You're anyway based here, you're stuck here. So, it's easier. So sorry for the delay as well in the morning. Yeah. So the session that I've been asked to chair is on the conservation aspects of mollusks. And I come from a conservation background, marine conservation background. The organization I work with is called Dakshin Foundation. It works on coastal and marine conservation issues here in India. And along with chairing the session, I'm also here to introduce Dr. Deepak Apte, who's going to give the plenary for the start of this particular session. I'll get to Deepak in a little while. Just to quickly set the context, well, mollusks, I did study mollusks as part of my master's dissertation. Mollusks were a critical component of my PhD work as well. After that, my tryst with mollusks have reduced significantly, even though I work in a lot of the island systems and do encounter a lot of mollusks. I don't primarily work on mollusks anymore, but I got into this field mainly because of mollusks, just because of the absolute fascinating nature of mollusks. And the group I studied are called boring organisms. They are not all that boring. They're coral boring organisms. And mollusks are one of those major groups that, that do play a critical functional role. And to a large extent, I think, I'm very happy that a conference like this is happening on mollusks, and even more happier that, Anand did think about having a special dedicated session for mollusk conservation. Quite often, a lot of the malacological conferences primarily deal about either the taxonomy or the, natural history or the biology of species. But I think we do really need a lot more youngsters to come on board and build the profile for mollusks. Insects also have their own, massive, recognition that they have as a critical group, but mollusks as the second, largest diverse group probably need a lot more attention. And I think a lot more conferences like this, a lot more youngsters here. I was very happy to see a video, a beautiful musical video on mollusks. First time I've ever seen something like that. So, fantastic effort, Arvind and team, to make that happen. It was spectacular, and I really enjoyed it. Similarly, I saw some lovely posters here. One of them about the behavior of mollusks and how mollusks were categorized as bold and non-bold, not so bold mollusks. So quite exciting things to see here, and happy that, a lot more, the field of malacology is now diversifying much more beyond the classical taxonomy and all of that used to happen when I was involved. So without much ado, I'll get into, so it's a privilege for me to be chairing this session, even though probably there may be better qualified people here. But I'll take this opportunity and also introduce Dr. Deepak Apte. I've known Deepak for the last, 15, 20 years, probably on and off. We keep running into each other, both work with coastal marine systems. He's probably the one, rightfully the plenary speaker as well. He's worked a lot on the ecology of mollusks, a lot of conservation related projects on mollusks, particularly the giant clam. And that's how I got to know about Deepak and his work while I was working in Lakshadweep Islands, where he had a grant from the Whitley Foundation and started the first dedicated marine mollusk, generally mollusk conservation effort, which involved a lot of mobilizing local communities, setting up smaller reserves for giant clams in the Lakshadweep as one of the major, critical functional groups on reef ecosystems. So from there, I've seen Deepak just take off, from a field researcher. He's just gone from one place to the other. And if I start putting together everything that he's achieved, it's going to take a while. But right now, he leads the Srishti Conservation Foundation. Deepak just mentioned, I thought it was very young, but I just heard from Deepak that it's 3 years old. They work a lot on, environmental issues, policy, and a lot of grassroots action as well. Uh, I know both island systems are sites where he worked, but many other sites on the mainland, I guess. Deepak has also been a very strong, he had been working with the Bombay Natural History Society for more than 30 years, around 30 years. He was the director of that institution, one of the oldest conservation institutions in India for about 8 years or so. And from there, he's been part of various national, state, and other advisory committees as well. Uh, he is on the CRZ Infrastructure Appraisal Committee. I think you chair that committee, right? And he's been chairing it for 8 years. And he's also on the Impact Assessment Committee, which is basically a nodal committee of all these various expert appraisal committees. So has a very strong, thumbprint, footprint, whatever you may want to call it, on India's policy landscape when it comes to a lot of the natural resources. I'm not going to list out all the different committees he's part of. I know that he's part of the Andaman Coastal Zone Management Authority. He's also part of the National Board of Wildlife for a fairly long time. So yeah, like I said, if I continue, the session is going to get delayed further, but without much ado, Deepak, please give him a warm round of applause and let's get started.
Thank you, Naveen. I think when you serve for 35 years, you're bound to be in some of these committees, being part of a larger national organization. The tragedy of, once you get into policy and director and CEO role, you're practically divorced from research. And most of it, then to deal with rhetorics of policy, policies are very complicated. And research play very little role, unfortunately, research plays very little role, unfortunately, in policy directives. Sad part of it, but that's a reality. And therefore, I always keep telling students that classical research, which is equally important, taxonomic research, equally important because it's the foundation of all biological sciences. But somewhere we have to blend management dimensions within our research. Unless we do that, this research, great in itself, you'll have great publications, you'll achieve all important milestones as a scientist, but your species and habitats will continue to decline and deteriorate because most of the core research or recommendation that we give never percolate in a decision-making process. And why I'm speaking about this before I go into presentation, it has a direct bearing on how our habitats and ecosystems will do over time, over next couple of decades, when it comes to the quality of it and species distribution abundance. Climate change is changing the entire narrative of distribution of species, and it's going to get worse in times to come. I have worked in the marine realm for almost 35 years, started my career as a young researcher. I did my MSc in bioresearch in marine. I have been diving for almost 35 years all over the world, and I have seen the seascapes changing pretty dramatically. And whatever research we do on a species, unless it is linked directly to the way it interacts with its habitat, I think taxonomic research was in terms of saving the habitat in itself. So this is one species which I was very passionate about. I saw this species for the first time when I was in 9th standard, when I went to Lakshadweep in 1979. I was that time only about 13-year-old. And one fisherman showed me and told stories about how they used to look at this species to navigate to the entrance of Lakshadweep because they used to have these large clams there. That really intrigued me as a kid. That's a fascinating species. Then I forgot about it as time passed, and I did masters in very different, though marine subject, but it's on brain cell necrosis and role of marine unsaturated polyfatty acids in recovery of brain cell necrosis. Very different subject, but it kept me connected to the science of marine conservation. I joined BNHS. That's the first time I got opportunity to look at this species. Very, very interesting species and very difficult species, I must tell. Though it's very large, grows to almost a meter. The largest species grows to a meter. The smaller one is relatively small, about 6 inches or so. Very long lifespan. I can operate from here. Okay. Okay. I'll speak about the species, but it's a very interesting, case for this particular group of animals. Uh, it's undergone a lot of revision in the recent times. There are a lot of confusing taxonomy for this particular species. There are about 4 extinct species. There are about 12 valid species totally globally, of which 2 are now, what we call it as the endemics. In India, we have primarily 5 species, maxima, which are widely distributed on the island ecosystem. We only have this species, this group, only in islands of Lakshadweep and Andaman Nicobar. It's not present anywhere else along the coastline. Crocia is restricted only in Andaman Nicobar Island. Gigas also restricted only to the Nicobar group of islands. And we have some, records of dead specimens of Hippopus. There are about 5 species. We don't know much about Gigas and Hippopus. We know fairly good about Crocia, Squamosa, and Maxima. What I'm going to present is really on Maxima per se, because these 3 are very different niche specialist species, so it will require very different presentations. My PhD was on this species, Stratacna maxima. We have been working on this species in Lakshadweep for the last 25 years. So this is one of the longest monitored marine species in that sense in India. There is no other species which is monitored continuously for 25 years in terms of its population ecology. And it is necessary because of very intrinsic characteristics of this species. If you look at the distribution, this is slightly old map, and we have to revise this now taxonomically. We are here. Bulk of the species are distributed in Andaman Nicobar into this part, and then in Lakshadweep. We have some historical references between Gulf of Mannar in Tamil Nadu and Sri Lanka. I'm not sure whether this species exists in Sri Lanka. Is anybody from Sri Lanka maybe, can provide information on that? But from other ranges, it's completely disappeared. And that's how this is a maximum distributed species. We considered originally this as a single species, but now it's more of a species complex. We'll come to that later on. It's really these, mantles are really spectacular for this. That's what actually attracted me in the beginning. Very interesting, just like corals, they also have symbiotic zooxanthellae. And interestingly, this is the only species in where, besides blood circulation system, there is a zooxanthellae circulatory system. And that makes this group of individuals relatively more resilient to sea surface temperature. I'll come to that in conservation issues. So these are the 4 species we have. This is Maxima, Squamosa, Crocia, and Gigas. This is the smallest one, grows to about between 3 to 6 inches. A very short life, between 5 to 15 years. And this is the one which has a life of 100 plus years. It's known to live about 200 years in wild, while Maxima and Squamosa roughly has an age of between 70 years. So they are really long-lived species, fixed on a substrate. So they become an excellent surrogate to monitor the health of the coral reef ecosystem. So the challenges of coral reef is that it's so heterogeneous in terms of its structure, species diversity, the assemblage, etc., that if you start doing monitoring purely for a coral reef context, it takes really, really long amount of time and data to interpret the change in the community structure of corals over time. But since these are classic surrogates, as Naveen has said, they are boring clams. Not all, I think Squamosa, sorry. How you go to the full mode? Sorry. Okay. So, except for Squamosa actually is present on the seafloor. It's a sand burrowing clam, while as all other clams are coral burrowing clams. So they have a great role in breaking down of the dead corals. So these are the two which we haven't yet found any live specimen yet. Maybe working in Nicobar should keep looking for those just slightly deeper water species. Well, again, a very interesting character. They found exclusively in tropical reefs, so you'll not find them anywhere else. Grow in shallow waters. Most of these species, except for this hippopus species, you will find the great abundance in a very shallow water range between 1 meter to about 10 meter. Below 10 meter, you'll not find them in great numbers, but you'll get the larger individuals in a deeper water. Permanently, part of their life cycle, of course, is pelagic. Though they are simultaneous hermaphrodites, uh, they will go through synchronized mode of spawning to achieve the maximum fertility. So first, females will start laying eggs, and that suppresses males to release sperm. And then once the whole egg laying is over, the chemical cue will then facilitate release of sperms. So fertilization is external. And that's one of the reasons that, the recruitment in this species is very, very low. It's an extraordinary low recruitment that we observed in this species. It has a very short larval life of 7 to 10 days. So in this 7 to 10 days, it has to settle on a suitable substrate. And it has a very, very fascinating substrate requirement. Each species has its own substrate requirement. I'll come to that in ecological part of it. But it has a very long adult life. 60 to 150 years is where their range in terms of, and very slow growth rates. Initially, the smaller clams like Crocia grows very rapidly, but all other species, if you see an average growth, is roughly about 1 millimeter or to 1 centimeter per year, depending on the species we talk about. And as they grow, as they mature, the growth even get so slow that at times for 10, 15 years, there's absolutely no growth in a shell of that particular animal. Recruitment is a classic challenge for this species, and that's one of the reasons why we have very interesting population profile for this species. Now, the taxonomy has origin, as I showed in the map, Maxima is probably one of the most common species across the entire Indo-Pacific realm. But in 2008, this Rao Quinoit described Tridacna costata from the Red Sea. And I'll come to that where the confusion about this Tridacna maxima rests. In 2011, 3 years after its discovery, it was synonymized with Tridacna squamosina. So what we think as Tridacna maxima is actually not just one single. Then prior to 2011, squamosina was a variant, considered variant of Tridacna elongata, which in itself is a synonym of Tridacna maxima. So if you go, this whole taxonomic and new species, we go circle within circle. In 2020, I think one is a paper absorbed bulk of the mystery of Tridacna maxima. So a lot of species. Now, Tridacna maxima, for example, recently found in Taiwan, south to the Solomon Island in 2013. It's now considered as Tridacna noya in Su et al. In 2014. So there are descriptions which are based on pure morphology. And I think morphology-based description has inherent problems, as you'll know for most of the molluscan groups where there are a lot of cryptic species exist. As two of my students, one, she is working on nacerids. When we started with classic taxonomy using, radula and other reproductive characters, we could not resolve, these complexes very easily because radula remains by and large, practically same and very close to each other. It's only through very deep molecular analysis that you started realizing that these are really the complexes and not just one single unit that we conventionally thought about for this particular species. So when I completed my thesis, I considered this as one single group because all this research came subsequent to. I could not do, unfortunately, a molecular work for the reason which are more of a policy reasons. Getting permission to work on scheduled species in this country is a nightmare. To take permission from ministry on Schedule 1 species. I eventually got, now we are working with the University of one of my students is working on this species. Then again, Tridacna ningalo, another new species described in 2014. Again, it has been annexed to Tridacna noya because of, again, morphology based. Then another Tridacna species were described by Hulseken in 2013. Now it's it still remain unresolved whether this is really a new species, and it came in a very insidious journal, this paper. Then Lorenzi, again, this is now considered as a valid species in 2016. So discovery of even the large clams are not new in that sense. The latest discovery was 2016 of Lorenzi. I mean, we know these are large animals growing up to a meter in length. They weigh almost more than 100 kg. But yet there are newer and newer species described from various parts of more isolated reefs, I would say, rather. Then again in 2020, this classic paper, uh, linked this Lorenzi back to rosewater, which was described previously into the similar region. So if you look at taxonomy point of view, it's very, very, complicated. And therefore, I feel that, and India still remains a huge gap within Indo-Pacific because we have bulk of the work done in most of the countries, except the Indian Ocean region. But what really attracts me is not just the taxonomy is more, kind of, I would say mechanical part of it, take tissue, do DNA. I'm not an expert on molecular part of it, so I can't comment on that. But the real challenge for species conservation is really how we understand how the species interact with its habitat and microhabitat. Now, it's a boring clam, as Naveen had said, plays very important role. So when I started looking at ecology, we then looked at how this jumps back to, sorry. So we then classified in terms of where this species actually is present on the corals. And, it occurs in different parts of coral. Sometimes, they prefer the large porous colonies on top of it, which is mostly dead and encrusted with microalgae. And some of them are anchored deep inside the live coral. So we started doing a systematic documentation through transacts to understand the distribution of these individuals across the coral preference. They almost 99% occur on Poraitus. We have not seen Tridacna maxima on any other coral species except some, Fossili-pora, etc. But 99% they are present on Poraitus lutea and Poraitus lichin, the two species which are present in Lakshadweep. Now, out of the 5, we have 3 species which are included in Schedule 1 of Wildlife Protection Act. It means intrinsically that molecular studies had been a challenge in the past for it because of permissions. Getting permission is very, very difficult. And island, again, when you have to set your research design in a very large oceanic ecosystem. Now, these lagoons are really massive. Now, this is in Agatti, where we used to have base in Agatti and Kaurati. Transport from here is very easy to other islands. Now, if you look at, the reef area relatively small on the crest, but the overall lagoon size here is more than 36 square kilometers. So how you design your sampling methodology when you have such a large area? Then you have to look at the characteristics of the species. As I said, maxima was almost entirely is a boring clam. It present only where there are Poraitus corals. So you eliminate all these sandy areas because absolutely there is no scope of Tridacna maxima being present here. Then all your sampling design then restrict to almost 30% of the reef in an atoll ecosystem. In Lakshadweep is slightly different because we don't have atoll. There's a barrier reef. So their sampling design is much more different than the sampling design that we followed here. So in Lakshadweep, it's essentially these clams are present only on this very thin reef crest that you'll see where there's a live coral. Beyond that is a deep water. It's a wall. It's basically a volcanic island. So clams up there only about 15 to 20 meters at that depth. Below that, there are no clams because it's all vertical wall beyond a point. And then we looked at population ecology, then impact of elevated SST, and then developed the species recovery plan for ministry. That was the primary objective of it. Now, 25 years we have been working on this species, and eventually we said that, look, it's only through, declaration of protected area in this country as a national park or sanctuary is practically next to impossible. considering a very large population displacement involves. So community-based management may be one of the options. So it's the first model actually in marine. We started working 2006, 2003 on declaration of marine protected area through community participation, which are meant for this specific species. This is the first time we realized that there is a canopy system in a reef, and you cannot understand some of these surrogate species unless you know the distribution of these species on the canopy part of it. Now, in a forest canopy, probably, is 40, 50, 60 meters, but it's here relatively short. But even in this short canopy of 2 to 3 meters, it's a very, very interesting distribution of product on this. Because they're fixed and they're extremely prone for heavy sedimentation, they prefer a very classic niche where they stay above the routine movement of sediment due to the tidal movements. So when we map this, the entire clams vis-a-vis the substrate, when we create a 3D profile of it, they occupy a very narrow niche between 0.4 to 0.6 meter from the seafloor. Bulk of the population, more than 90% of the Tridacna population. So if you look at the three-dimensional picture of a canopy, they are just avoiding proximity of a substrate because of the very high sedimentation movement during the tide. Now that makes them again extremely vulnerable because your 90% population is a very narrow band of a reef canopy. So how we are going to look at in terms of a conservation management? Because bulk of the problem of this canopy is that the navigation channels has to be created for movement of vessels, whether it's a fishing vessel or whether it's a cargo vessel. And the biggest impediment in this vessel movement is Poraitus lutea, because they are massive, they have to be first removed. So what is happening over a time for every single lagoon which requires a navigation channel, all these large boulders have to be routinely removed and placed it somewhere else. So we technically are actually removing some of the most important habitats for the species. So it's not just the elevated sea surface temperature. How we look at the management of the lagoon for navigation purpose also has a direct bearing on this species. Now, if you look at the substrate profile, as I said, it's basically for Poraitus with dead top. So this is something which they will not prefer. Maybe very few clams you'll see which are present within these small gaps, within this large coral colony. But bulk of it will be into the Poraitus top. So they will prefer settling onto a substrate which has got fairly uniform dead coral top. And lutea forms almost, look at almost 90%, preference is given to one single species. So it's almost like a co-evolved species, Poraitus, lutea, and Tridacna maxima. Anything you want to do to save species, you have to look at saving Poraitus. And Poraitus has its own challenges. I'll come to that. Because it's logical because clams also grow very slow, and this coral also grow very slow. If they occupy a fast-growing coral, coral will overtake the Tridacna. That's how they evolved in a very interesting fashion that they are tailored with the slow-growing coral. But this coral, because it's slow growing, and because of this, elevated sea surface temperature frequency which is increasing, we have now issues with, the substrate in itself. So this is how we then classify it, in terms of anchorage selection. How deep really these clams are. Shallow anchored means they can get easily dislodged, and then eventually they will die because it's not basically a sand-dwelling species. It requires a very deep anchorage. And then we look at the best preferred anchorage and which substrate against which, because they bore. When the tiny clams settle down on a substrate, they will release an enzyme through which they will, extend its tube feet, and then they will anchor itself. So initial period, they will move actually with to certain distance to find a suitable anchor. This is one species which actually try to find out an anchor, search an anchor which is suitable for boring. And once it's, that the byssus is, gone inside the reef, then it will settle down and then it get fixed to a substrate. So all these micro aspects needs to be understood, especially for a long-lived species, because they're fixed, their life is very long. You need to understand these microclimatic conditions. how they, select and choose the site for recruitment. And why this is important? Because when we studied this for almost first 10 years, the recruitment for this clam is very low as 1 clam per hectare. That's how very low recruitment this species is. And it also requires a good, healthy adult population who have a successful recruitment because of its synchronized method. Convict surgeon fish, it's not just the clam which is important for us. How these surfaces are maintained of the microalgae becomes very, very important because they are really tiny, what we call it as a planktonic form which settles on a substrate. So if the substrate is, overgrown with microalgae, then clam will not be able to settle down on a suitable substrate. And when we started looking at what makes this substrate microalgae free, then the role of herbivory becomes very, very important. And this convict surgeon fishes, for example, is a very interesting species. During the high tide, they're all in a deeper water. They go as deep as 30 to 35 meters, where you'll see their shoals. But during low tide, when water starts draining out, all these fishes will come in shallow areas to feed on the coral heads. And the shoals sometimes range to 100,000 to 100,000 individuals. We use the same technique they use for bird flock monitoring for measuring the size of the shoals of this species. So this species is absolutely vital because this is single most herbivore, which is present in a large number, which actually do maintenance for habitat. Now, this is a classic habitat on which Tridacna will grow. Now, this habitat has to be clear of all microalgal growth. So routinely, this role of herbivory then becomes very, very important. And it's not just, this is based on the actual browsing activity that we carried out into different transacts. For example, this is just a small illustration. You'll get all the details in my thesis. And from low browsing activity to high browsing activity. And if you look at the count, recruitment count, it directly coincides where there is a high browsing activity, where these coral tops are pretty clean of microalgae. That recruitment has been extremely successful. So I think these insights into ecology are very important if you need to look at the species conservation. And this species of fish, for example, is again, not go back. That's okay. Oh, this is the back. Okay, sorry. Yeah, sorry. Yeah, so when we look at the recruitment vis-a-vis adult density, it's a very low recruit species. And against the browsing intensity, we have a maximum recruitment where there is a very high browsing activity. But unfortunately, this convict surgeon fish is a very delicious fish. So large amount of, and they come in large shoals. So very easy to pick them up. In a single net, you will get about 1,000, 2,000 individuals caught from the reef. So management of convict surgeon fish therefore become very, very important if we need to look at the habitat management for this particular species. There is no other fish we have seen in last 25 years, except maybe some, species of parrot fishes like Indian parrotfish, because these clams are in shallow waters. In deep water, we have bumphead parrotfish and those large humpback parrotfish, larger herbivores, redwood triggerfish. They do a great role of herbivory in a deeper water, but deeper water, we don't have these clams in great number. Most of them are in shallow water. And therefore, some of these species which prefer shallow water for foraging becomes important in terms of management point of view. So how we can work with communities to ensure that the catch of this species is, this particular species of fish is to be regulated. Which time of the year you require those substrate, because it's not that this species recruit throughout the year. It's a very, very, specific time of the year that this species spawn. And it's only the full moon time in the month of January, February. They will select probably one day. It's just one day phenomena that all the clams will spawn. And within 7 days. So that period of a month prior to it and month post to it is very important when these convict surgeon fishes play a great role in maintaining the habitat. And when we looked at what is then, how, from where the recruitment is, and what is the movement of this convict surgeon fish. Very interesting. They are not uniform distributed across the lagoon. They're all preferring the entrance of the lagoon through which there is a huge draw of water during low tide and high tide. So this species require a very strong currents for recruitment, contrary to our understanding that it will settle down in a very calm water. These are the areas through which the convict surgeon fishes will come from the channel, two channels, and then they will forage into nearby areas. And bulk of the recruitment data that we have is, I think these fine-tuned aspects of understanding of the species are very important. Otherwise, for such a long-lived species, in a mosaic of kind of habitat, general coral reef restoration and conservation policy will not work for this species where requirements are very, very specific. The real challenge then is how this ESST is going to impact this species because of presence of zooxanthellae. All tridacnas have inbuilt, they have zooxanthellae, and they rarely feed. Most of the time they're autophagous, and this zooxanthellae actually produce nutrients for the clams. But the presence of zooxanthellae makes them equally vulnerable like corals in terms of the bleaching. Fortunately, we actually have not noted bleaching related mortality in the adults. There is a problem of recruitment, which is of a great concern to us because during the, elevated sea surface temperature, they stop spawning. And there is no recruitment that we have seen for next year or so. So it's basically fall in a recruitment is one of the factors that we are concerned with for this species, which already low recruit species. And then, there is a detailed methodology. We have tweaked the methodology a bit because the English ethel method, which we started using, it requires a lot of funds because, working in a reef ecosystem is not, you can't do that at low cost. It requires certain amount of manpower, certain amount of infrastructure, certain amount of equipment. And how much of area you can cover in a day, and depending on your sample size, will decide the cost effectiveness. And when we know quite well that for conservation research, funding is not very easy to come by. The big challenge, not just in India, I think it's globally, we have a challenge of funding. So then we decided to say, look, without compromising the viability, statistical viability, how best we can adopt a method in a different ecosystem. Bulk of the studies are more on a barrier reef. There are not much studies in an atoll ecosystem, except a few in Maldives and maybe the small island nations. So we modified this whole methodology a bit, and we used, and that's been published in 2019 and 2018 through two series of papers in terms of a modified method for maximizing efficacy of clam count without compromising the data, but at a low cost, so that research long-term monitoring can continue. But this elevated sea surface temperature is really something which is, we yet don't know much about it because clams are relatively less vulnerable like corals. And then we analyze this whole, this is how the populations that we are, monitoring of it, very, very stochastic. There is no, trend that you'll see very easily unless you deep dive into data analysis, which two of my students are currently looking at. So what happens is that this, very frequent ESSTs. Now, one we have in 2098. Unfortunately, we don't have data for this piece for the maximum bleaching period. We started work only in 2003. And unfortunately, whatever existed through kind of an unpublished data, we sourced that. But post that, we had three major bleaching events. One is 2000, then we have one in 2016, and then we have in 2020. So what is happening is, after bleaching, you'll see there's a fall in the population dramatically. Basically, it's because of the recruitment failure. Any populations are very small. So any decline in the recruitment influence, and it takes a significant amount of time for the populations to recruitment to start. By the time it starts, again, you have another bleaching event. So it's basically a very undulating pattern of population, that 25 years that we are following. But overall trajectories, if you look at in terms of the species, they are definitely declining from where we started across all the islands. And when it's a very small population we are talking about. Clam between, I would say, 200 to 80 to 200 clams per hectare. It's a very, very small population. And if you split that into adult, subadult, and juvenile, then adult population is very, very low. Now, if you look at where our problems of ESST, rest. That's what I've shown. So what is happening is traditionally, if you look at 1930s and between 1930s to 1990s, the average SST was hanging between 27 to 28 or 28.5. That's the temperature where there is no bleaching. So neither coral will bleach nor clams will bleach. Corals will start bleaching at 29 degrees centigrade when SST reached to that. And if you look at post 1990, the temperature regimes have almost moved from 27 to 28.5 to 29. So naturally, the entire Lakshadweep and to that matter, east coast of India, SSTs are settled 29 and above. So no matter whether there is an El Nino or no El Nino, this natural increase in SST will put pressure on bleaching episodes more frequently than before. Because if you look at this, this is absolutely crystal clear indication that reefs are transiting into a new era of sea surface temperature. So our conventional ways of managing reefs or restoration of reefs or restoration of species which are vulnerable because of SST are not going to be useful. We have to look at new ways of restoration. And I'll come to that as a conservation strategy, maybe slightly in last couple of slides. And that's how it's a classic indication of how our SSTs are settled now at much higher regime than what conventionally it was about 4 decades ago. And now that becomes a very important understanding. So if you do not understand this aspect of it and keep on recommending as a policy to ministry that you do sea ranching without knowing that you are actually making sea ranching, more vulnerable because now our thresholds are very different. You need to look at a very different approaches for conservation. I don't know what it is. And slowly we started understanding. Now one of my students who's been working on the zooxanthellae based resilience to SST, very interesting perspectives coming from different countries, from Australia, from Egypt, etc., etc. So, we already got 1+2 intercepted El Ninos in a study. It's very, very important. For a long-lived species, you require long-term monitoring. It's my first suggestion to young researchers, then don't put any research recommendations based on 2 or 3 year studies. For taxonomy, that's fine, that this area is important, type locality, etc., etc. Or your species where you find it in great, abundance with a good quality habitat. So far as saving those sites, recommendations are okay. But without understanding the complexity of the habitat where they occur, sometimes these recommendations become double-edged sword. If some government invest a lot of money into restoration of habitats, down the line 5 years, you'll realize that habitat is back to square where you started with. That's a classic case for coral restoration happening in this country. Crores and crores rupees are invested into coral restoration. But we are restoring same species in the same area, which were exposed to only between 27 to 28 in the past. Now they're exposed to 29 recurrently, almost annually. It will make those species survival very, very difficult. Therefore, we need to look at non-conventional, sometimes very controversial. People will criticize. Doesn't matter. Research is about experimentation. That's what I believe. Without which these reefs have absolutely no scope in terms of our intervention. But very interesting work is coming out through one of my colleague, Naveen's colleague, Rohan, is working in this islands for a long period of time. And he is doing coral monitoring, I think, almost since 1998. And his data, he's published a really wonderful paper a couple of years ago, which is suggesting that naturally, that these reefs are transiting from Acropora-dominated seascape to Poraitus-dominated seascape. Because Poraitus are relatively much more resilient to ESST, then Acropora is very vulnerable. Acropora will bleach and die at 29 if SST prevails for more than 2 or 3 weeks. Poraitus doesn't get impacted to that level where Acropora gets. So these reefs are natural transit ecosystem. Deeper water, corals are being shifted to soft corals because they don't have zooxanthellae associated. They do exceedingly well because very large niche habitat is now available for other species which are resilient to SST and porritus. So we need to understand this natural moment of ecosystem is very slow. It will take probably another 500,000-600,000 years for it to transit into completely SST tolerant reef ecosystem. But that is naturally happening. I don't know what is happening in Andaman. I have not studied Andaman to the length where Etri and Naveen's group has studied. But it is pretty much coming to the light that systems are also responding in a very different fashion. And one of the key factor, what has been recently found again by Gaurav, who worked with me now, he is in University of Guam, is that the resilience of corals depends on the type of zooxanthellae associated with it. Most in ocean, we have a clade C, which used to be very, very dominant. Now, clade C is something that allows corals to grow very fast, but they are less resilient to temperature. So 29 threshold, these zooxanthellae will expel coral polyps, go to deeper water or wherever it is, and that leads to bleaching. But clade D, and it came through a very systematic monitoring of where is clade D present. Dominant clade D prevalence is into Gulf of Kutch in India. If you see the map of India, it's in Gujarat, followed by the Makran coast in Pakistan, entering into the Persian Gulf and Red Sea. Now, when we started deciphering data as to why these particular areas remain relatively less impacted, all the way from 1900 bleaching till 2025 bleaching episodes, is not much impact on these reefs. And the answer then rests into the clade, because these reefs have got clade D prevalence. It's called thermophilia. Now, they have got far more resilience to temperature than clade C. Now, there is a lot of global research happening that can we then look at, because these clades are present naturally into the marine environment. It's just that the coral polyp acquire C because for whatever reason that may be. What are the chemical cues? I don't know. But a lot of research now happening to see whether can we inoculate these areas with clade D. Of it, and can these individuals acquire clade D to create more resilience to the elevated sea surface temperature? A lot of research now happening in this domain. And what we found out based on Gaurav's data, which he analyzed data all the way from Gujarat to Lakshadweep, is that in Lakshadweep, it goes with what Rohan's data suggests that they're shifting to more resilient. That Lakshadweep corals also naturally are acquiring more clade D than clade C. The only disadvantage of clade D is that it will slow the growth of coral. And that's how it built the resilience. So there are always a trade-off in conservation. So conservation policy need to look at these intricacies of what makes these species and habitats vulnerable. And unless you look into this, all that we end up doing is investing on something which may not yield good amount of results in a times to come. Yeah, and then Andaman, we studied it for a very brief period of time. The cost involved are too much for this species in Andaman because of barrier reef, diving involved, etc., etc. But Andaman, these species are doing very, very bad. I don't know what the reason is. I haven't got enough time and data to comment on that. But this one paper that we got, very old paper, 1983, Ramdas from CMFRI, who actually collected data for all these three species from Andaman. Look at 1983 data and our current data, 2014-15 data for across different species in Andaman Nicobar Island. And common species like Crucia maxima, we almost lost 99% population of these species from Andaman Nicobar compared to the historical. This is the only document historical we have, which is a great to have this kind of a data. So there's definitely something wrong in Andaman Nicobar. What's happening there? We don't know. Somebody will have to work on these species for a long term. But, it's in a very, very bad shape. Squamosa is almost virtually gone. From the shallow reef, I have not seen in 5 years, maybe 10, 12 individuals in all these areas that we work. Maxima to certain extent. There, Croatia is good because it's a, intertidal clam. But it's still, look at the decline both in Andaman and Nicobar. It's catastrophic. Lakshadweep is fortunately not that bad. We still have fairly decent population. Anyway, it's a low density species in the atoll ecosystem between 80 to 260. 300 is a maximum best density that we have seen in Maldives, etc., etc. So Lakshadweep is fairly good. The species still have a decent chance of surviving. This one area we need to look at very, very classical. And that's probably my last slide, is that, these tropical reefs are transiting into a new area, new era, where our SSTs are going to settle 28 degrees, 29 degrees above. And that's fundamental question that we need to address as a conservation challenge. How then our species in a marine realm, which are vulnerable to elevated surface temperature, are going to survive? And it's not just one species. We are talking about the entire seascape. So all the previous discussion in coral reef conservation, the context and narrative has to change completely, because conventional approaches to this is not going to work, whether there is El Nino or no El Nino. We will have this frequent bleaching episodes happening in this reef ecosystem more frequently. And therefore, mariculture may be a viable option, but if we inoculate this with clay tea and then release it into the wild, maybe these are the R&D that we need to explore as a scientific community, not directly intervene into the wild, but at captivity, we have to start working, experimenting on corals, whether they can acquire clay tea, whether tridacna acquiring clay tea, how they're getting the resistance to the increased threshold of SST is a challenge. I think it's a new era for conservation that we are talking about. And we need to be mindful as a young researcher that at policy level, I'll just conclude in 3 minutes. I tell you the dilemma at policy level, because I've been part of a number of committees at national level, at state level. Usually these committee meetings happens, if at all it happens once in maybe months, 2 months, once all these senior officials will come. The window of time to deliberate on very technical matter for us per agenda in the committee which I chaired, impact assessment. The maximum time we get to assess a case is not more than 25 to 30 minutes. In 25 to 30 minutes, if I had to look at these fat documents and make sense out of it, and then decide on certain things or recommend certain things, I think it's a huge challenge in governments. Therefore, we cannot put recommendation, wish list as a recommendation. That's the first and important thing. You may have just one recommendation, but significant enough where policy can play a role. Many of the recommendation where policy has no role. So many times we end up saying something where government doesn't know what to do. Most of the time when this matter come to us in central government, in some of these committees, the very question chairman will ask, what do you want me to do? And I think that is a question missing in bulk of our recommendation, because you see the research recommendation, the list will go on to 30, 40, 50, 60 recommendations. Please understand that if you want policy to change, the narrative and the presentation of your data required to be in a very different fashion and format, which the bureaucrats they don't understand science. Please take it from us. They are either engineers or IS officers or from different disciplines. They will not know what you're talking about. What is tridacna? What is zooxanthellae? What is clade D? What is clade C? What will they do about it? Unless we tell them specifically, okay, this is how. So please, try to blend. Wherever there is a habitat conservation you talk about as a species will not exist with a good habitat. Then it has to come in a specific policy context. It's a special skill. You'll need to understand provisions of these different acts, which most of the researchers don't know what is CRZ, don't know what is Forest Conservation Act. They don't know about what is National Board for Wildlife, what is Wildlife Protection Act, what are the principles of those. I think there is a small training session, if you do, I think for these young researchers, you're doing a lot of training programs. I think it's very important. They have to build the understanding. This is the big gap today we see, between the wonderful research all of us do here vis-a-vis policy will come very different shape and format. And today, what is a beautiful site for your type locality will not exist down the line 5 years because some port is going to come there, or some infrastructure project is going to come there. So it has to be understood at a policy level. But please work on a long-term basis if you have a choice of doing it, because taxonomy is great. That's okay. That you can do. Identify species, describe species, job done. But ecological studies require really, really long-term, investment of time and resources. Thank you.
Thanks, Deepak. From Lave, sorry, all the way from Giant Plum Lab, Lave to how to make policy recommendations. It was quite an insightful talk. Thanks for that, Deepak. And I'll just happy to take questions. If there are any, is there time for questions? So then I'll